Hello friends, welcome to Aviksha Avi YouTube channel. Hope you are doing well. In this video, I am going to discuss about number system, which is helpful for both CTET examination and for state level TET examination also. Firstly, I would like to explain about content. Then I will go for the problems which covers both sectional problems as well as previous year exam problems from this chapter. Let's begin. The total weightage of this chapter is 5 to 6 marks. It means 5 to 6 questions they will ask. Among this, topic wise weightage is shown here, that is from the information of a number. They did not ask any question. They did not raise any question from this topic, but this is the base for all these topics. From the divisibility rule, they raise 1 or 2 questions. From remainder theorem, they will raise 1 question, and from square and square root, they will ask 1 question. From the topic face and place value, they will ask 1 question. From the simplification, they ask 1 question. Firstly, we would start with the information of the numbers. In this information of numbers, first topic is real numbers. In simple words, the real numbers can be defined as any number on the number line is nothing but the real number. The number may be positive or negative or fraction. This I will show with the help of the number line. Now I will just write a number line and I mark the numbers 0, 1, 2. Minus 1, minus 2. Now, here 0.5. It is nothing but 1 by 2. Like this. I just marked the numbers here. Now, any number on this number line is nothing but the real number. It may be positive or negative or it may be fraction. So, totally we can say that any number on the number line is nothing but the real number. Now, one more important point under this is pi is also a real number. Pi is also a real number. Why we called pi is also a real number means this pi can be written as 3.14, which is nothing but 22 by 7. It is a fraction. Fraction means I already said any number on the number line is nothing but the real number. So it is a fraction. So it is also called a real number. This is all about the real numbers. Next we move on to the natural numbers. Okay. Natural number means all positive numbers, that is starting from 1 is referred as a natural number. This I will show with the help of the number line. Just I will write a number line 0, 1, 2. Here minus 1, minus 2. Now, here from 1 up to infinity, we call it as a natural numbers. We call it as a natural numbers. But all numbers must be positive only. Here any fraction or negative numbers does not come in natural numbers. This is all about the natural numbers. It starts from 1 up to the infinity and here no fractions or negative numbers does not come. It is nothing but the natural numbers. Next we move on to the whole numbers. Whole numbers. In simple words, we can say 0 plus natural number is equal to the whole number. That is 0 plus natural numbers. Natural numbers is equal to the whole numbers. This also I will show with the help of the number line. Just I will write number line 0, 1, 2. Here minus 1, minus 2. Okay. From 0 up to infinity, we call it as a natural numbers. Here also no fractions and no negative number come under the whole numbers. This or the from 0 to infinity, we call it as the whole numbers. And here also no fractions and no negative numbers come. This all about the whole numbers. Next we move on to the integers. Integers means all positive, negative and 0. There but no fractions, that is positive numbers, 0 and negative numbers. Togetherly we call it as integers. Here integers, here no fractions come. For this I will just give an examples. Suppose if you consider 1, 2, 3, this all are the positive integers. This all are the positive integers. Next, -1, -2, -3. They are all the negative integers. Next, 0. 0 is not a positive, not a negative, but it is a non-negative integer. 0 is a non-negative integer. Suppose if they given 1 by 2 is a integer, it is not an integer because it is a fraction. So 1 by 2 is not an integer. Okay, is it clear? Because it is a fraction, so it is not an integer. Next we move on to the rational numbers. Rational numbers means P by Q form of numbers where P, Q are integers and Q not equal to 0. This is the definition for the rational number. P by Q form of the numbers where P and Q are the integers and Q is not equal to the 0. If any number satisfy these conditions, then it call it as a rational number. For the better understanding of this, I will just explain with the help of the examples. Suppose I consider this 5 by 6, 1 by 2 and 6 by 5. These all are the rational numbers. Why these are all are rational numbers means because they satisfy the condition called this number is of the form P by Q. So here if you observe 5 by 6, 1 by 2, 6 by 5, they are all in the form of P by Q. So first condition is satisfied. Next, where P and Q are the integers. Here if you observe this 5 and 6, 1 and 2, 6 and 5 are all are the positive integers. So second condition is also satisfied. Next, if you take Q is not equal to 0. If you observe here, the denominator does not equal to the 0. So all the conditions are satisfied. So this all are the rational number. Now it is clear for you. Okay, now I will give one more example, that is 1.2. Now my question is, this 1.2 is rational or not? Can you guess? Yes, this 1.2 is a rational number. This is a rational number. Why this is a rational number means because 1.2 can be written as, when we shift this point to the right side, it becomes 12 into 10 to the power of minus 1 and 12 into 1 by 10, which is equal to 12 by 10. So we can easily written 1.2 is equal to 12 by 10, which is of the form P by Q. P by Q is satisfied, and here 12 and 10 both are the integers and Q is not equal to the 0. So it satisfies all the conditions. So 1.2 is also a rational number. This all about the rational numbers. Now some of the important points are there under the rational numbers. Just I will note down. First important point is under the rational numbers, all perfect square numbers and cube numbers are rational only, are rational numbers only. You have to remember this point, that is all perfect square numbers and cube numbers are rational numbers only. This I will explain with the help of the example. For example, if you consider square root of 4, this is a perfect square number. Now the square root of 4 is equal to 2. Now this 2 can be written as 2 by 1. Now if you observe, this 2 by 1 can be written as in the form of p by q. This is in the form of p by q, where it satisfies the condition of the rational numbers, where p and q are the integers and q is not equal to the 0. So square root of 4 is a perfect square number, is also called as a rational numbers. Similarly, I will give one more example, that is cube root of 27. Cube root of 27. This cube root of 27 is 3. 3 can be written as 3 by 1, which is of the form p by q. Here also this is of the form p by q, and where it satisfies the conditions of the rational number. So finally we can conclude that all perfect square numbers and cube numbers are rational numbers only. Okay, you have to remember this point. Now I will give one more important point. Cube root of 4. This is a rational number or a not? Can you guess it? This is not a rational number because it is a perfect, it is not a perfect cube. It is a perfect square, but it is not a perfect cube. So it is not a rational number. Why it is not a rational number means it is not a perfect cube. Okay, so it is not a rational number. Next important point under rational number is all repeating numbers or rational numbers. You have to remember this point, all repeating numbers or rational numbers. Here repeating number means after the decimal point, if the number is repeated, then we call it as a repeated number and it is represented as x bar. This I will explain with the help of the example. X bar is equal to, x bar means it is the symbol of the repeating number. We represent x bar. X bar is equal to 0.3333. Here after the decimal point the number is repeating like 333. So we call this as a rational number because all repeating numbers are the rational numbers. I will give one more example for this. X bar is equal to 0.232323. Here 2 digit is repeating after the decimal point, 2 digit is repeating. So repeating numbers are called the rational numbers. I will give one more example, that is 0.234234. This all are the rational numbers only, because after the decimal point the numbers are repeating. So we say that all repeating numbers are the rational numbers. One more important point under rational number is Infinity. Infinity is not a rational number because its value is going on. So it is not a repeating number. Firstly, infinity is not a repeating number. So infinity is not a rational number. Okay. This all about the rational numbers. Next we move on to the irrational numbers. Next is irrational numbers. Irrational numbers means non-repeating numbers are called the irrational numbers. Non-repeating numbers are called irrational numbers. Here, non-repeating numbers means after decimal point the number would not be repeated. They are nothing but the non-repeating numbers. Example for this non-repeating numbers is 1.234786 like this. Here after the decimal point the number would not be repeated. So this number we call it as a irrational number because it is a non-repeating number. Now one more important point under this irrational number is non-perfect square number and non-perfect cube number are always irrational. It means if a perfect square number and cube number there, then it is called a rational number. But if non-perfect square number and cube number there, then it is called a irrational numbers. Okay, for the I will give example for this non-perfect square numbers and non-perfect cube numbers. Example, square root of 3. It is not a perfect square. And one more example is square root of 11, cube root of 16, square root of 2. These all are the non-perfect square numbers and non-perfect cube numbers. So if non-perfect square numbers and non-perfect cube numbers come, they are referred as the irrational numbers. So they are all are the irrational numbers. Okay. Now one more important point under this is irrational number is, this is a previous year question. Pi is a famous irrational number. Suppose if you refer once question paper, this is one of the compulsory question. Pi is a famous irrational number. Why we call it as this is a pi is an famous irrational number means, I will just explain it. This pi can be written as 22 by 7. 22 by 7 can be written as p by q. This is of the form p by q, where it satisfies the conditions of rational number, that is p and q are both are the integers and q is not equal to the 0. It satisfies the condition of the rational number but not the irrational number. But we call pi is a famous irrational number because when we divide 22 by 7, it gives 3.141595 and its value, the value of pi is continue up to infinity. Okay. So here a non-repeating number is come. So we say that this pi is a famous irrational number. Okay. After decimal point, non-repeating number is come. So it is a famous irrational number. So is it clear? Now this all about the irrational numbers. Next we move on to the prime numbers. Prime number. Prime number means the number which cannot be divided by any number except one and itself. It means, suppose if you consider any number, that number should be divided divisible by 1 and itself, but it does not divisible with any other numbers. It is the meaning of the prime number. This I will explain with the help of an example. Suppose if you consider 2. This 2 is divisible by 1 and 2 is divisible by 2. It means itself. Apart from this, 2 is not divisible with any other numbers. So according to the definition of prime number, the number which cannot be divided by any number except 1 and itself is called a prime number. So 2 is a prime number. Why we call a 2 is a prime number? Because it is divisible by 1 and itself. Apart from these two numbers, they did not divide from any other numbers. So 2 is a prime number. Now I will give some more examples for the prime number. Examples: 3, 5, 7, 11, 13, 17, etc. These all are the prime numbers which cannot be divided by any number except 1 and itself. So these are the prime numbers. Okay. One more important point under prime number is 1 is not a prime number. Why this is 1 is not a prime number? Because 1 is divisible by 1 and 1 is divisible by itself. It is nothing but. Okay. Now if you observe, for any prime number, it has two factors. Suppose if you observe this 2, it has two factors, that is 1 and the 2. But if you observe for 1, it has only one factor, that is from this both we can write one factor as 1. So it has only one factor. For every prime number, it has two factors. Then only we call it as a prime number. But for 1, we have only one factor. So 1 is not a prime number. So 1 is not a prime number because it has only one factor. It has no other than 1, it has no factor. So 1 is a prime number. 1 is not a prime number. 1 is not a prime number. Next important points are 2 is the least and only even prime number. I already said that 1 is not a prime number. So 2 is the least and only even prime number, and also 2 is the first prime number. Two is the first prime number. One more important point is except 2, all prime numbers are odd. If you observe, I just above examples, except 2, all the prime numbers are odd only. Now this is 2 is an even prime number, but 3, 5, 7, 11, 13, 4, 17 like this, these are the odd prime numbers. So we say that except 2, all prime numbers are odd. Next you have to remember that from 1 to 50 we have 15 prime numbers. You have to remember this. From 1 to 100 we have 25 prime numbers. From 1 to 200 we have 46 prime numbers. From 1 to 50 we have 15 prime numbers. From 1 to 100 we have 25 prime numbers. From 1 to 200 we have 46 prime numbers. Now based on this, in the previous year they raised one question. The question is, how many prime numbers there between 50 and 100? This is the previous year question. Okay. We already know that from 1 to 50 solution, from 1 to 50 we have 15 prime numbers. From 1 to 100 we have 25 prime numbers, but they ask to find prime numbers between 50 to 100. We have to find this. So for this we just subtract from 25 minus 15, we will get the prime numbers between 50 to 100. Okay, that is 25 minus 15 is equal to 10. Therefore 10 prime numbers there between 50 and 100. Here they given 1 to 50 we have 15 prime numbers, 1 to 100 we have 25 prime numbers, that is 1, 50 and 100. From 1 to 50 we have 15 prime numbers. From 1 to 100 we have 25 prime numbers. They ask to find the prime numbers between 50 to 100. So to find out this, we have to just subtract this 25 minus 15. We will get the answer. This all about the prime numbers. Next we move on to the test for the prime numbers. To check whether given number is prime or not, we have some steps. Please first note down the steps, then we will explain with some examples. To check P which denotes any number is prime or not, we have some steps. First note down these steps. Step number 1. Firstly find square number greater than P, say x square. Second step, find square root of x square, that is x. Step number 3, take all prime numbers less than x. Step number 4, check whether P is exactly divisible by numbers which taken in step 3 or not. Step number 5, if they divide then P is not prime. If they not divide then P is a prime. Now you have to just note down these steps. I will explain these steps with the help of an example. Example is given P is equal to 193. P means it may be any number and we have to check P is a prime or not. To check P is equal to 193 is prime or not, I just follow the above steps which I given previously. Now step number 1. I just apply these steps. Step number 1. In step number 1, we have to find out square number greater than 193 and name that number as x square. That is square number greater than 193. What is the square number greater than 193? That is, which is equal to 196. 196 is the square number greater than 193. Now I name this 196 as x square. That is x square is equal to 196. Okay, this I written with the help of the step number 1. If you want, you can read once again the step number 1 and then we will go for it. Okay. Next step number 2. This step says that we have to find out the square root of x square. Here x square is 196. That is square root of 196 is 14. And say it as a x. That is x is equal to 14. This is also according to step number 2. I will just return. Step 3 says that we have to take all prime numbers less than x. It means we have to take prime numbers less than this 14. So prime numbers less than 14 are 2, 3, 5, 7, 11 and 13. These are the prime numbers which are less than 14. Okay. Next, step number 4. Step number 4 says that check whether p is exactly divisible by numbers which taken in step 3 or not. It means we have to check whether the numbers which are taken in step 3, that is 2, 3, 5, 7, 11 and 13 are exactly divisible by 193 or not. So for this, I just check 193 is divisible by 2. No, it does not divisible by 2. So it does not divisible. Next, 193 is not divisible from 3. Similarly, 193 is not divisible by 5 or 7 or 11 and 13. So none of these numbers are divisible by 193. So according to step number 5, they said that if any number not divide, then p is a prime. So 193 is a prime. Why this 193 is a prime number? Because none of these numbers divide the 193. So we call it as 193 is a prime number. This I written according to the steps. Okay. I will give one more example to test that the given number is prime or not. We have now the question is test 87 is prime or not. Now I just apply the steps. Step 1. In step 1 we have to find out the square number greater than 87. That is square number greater than 87 is 100. Square number greater than 87 is 100. This I written according to the step number 1. Next, step number 2. We have to find out square root for this 100. Square root for 100 is 10. This is written according to the step number 2. Now step number 3. We have to find out prime numbers less than 10. So prime numbers less than 10 is, what are the prime numbers less than 10? 2, 3, 5, 7. These are the prime numbers which are less than 10. Next, step number 4. We have to check whether this 2, 3, 5, 7 are divisible by 87 or not. Now I have to check, that is 87. Does 87 divisible by 2? No. It does not divisible by 2. So it does not. Then does 87 is divisible by 3? Yes, it is divisible by 3. That is 3 ones are 3, 3 29s are 87. So it is divisible. Then 87 is divisible by 5? No, it does not divisible by 5. Then 87 is divisible by 7? No, it does not divisible. So here 3 is divisible by 87. So according to step number 5, if they divide, then P is not prime. This is according to the step number 5. So step number 5 is, if they divide, P is not a prime. So here 87 is not a prime. So here 87 is not a prime. This all about the prime numbers and test of the prime numbers. Based on the test of the prime numbers, one question is compulsory asked in the CTET examination. Okay, you have to follow these steps. Okay. Next topic is co-prime numbers. Co-prime numbers means if HCF of a given number is 1, then they are said to be co-prime. Here HCF means highest common factor. For this I will explain with the help of the example. I just take the example 4 and 6. Now my question is, check these numbers are co-prime or not. To check these numbers are co-prime or not, I just written 4. 4 can be written as 2 into 2. 4 can be written as 2 into 2 into 1. Okay. 6 can be written as 3 into 2 into 1. Yeah, 6 can be written as 3 into 2 into 1. Now I just group these numbers like this, 1 and 2. Similar numbers I just do group. Now here the highest common factors of this 4 and 6 is, that is HCF of 4 and 6 is 1 and 2. Highest common factor of 4 and 6 is 1 and 2. So the condition for the co-prime numbers is, the HCF of given number is 1, then only we call it as a co-prime numbers. But here the HCF of 4 and 6 is 1 and 2. So 4 and 6 are not co-prime. Not co-prime. Is it clear? Okay. Now I will give one more example for this. Next, one more example is 3 and 8. Check these numbers are co-prime or not. To check these numbers are co-prime or not, I just take this 3. 3 can be written as 3 into 1 and 8. 8 can be written as 4 into 2 into 1. Now I just group these numbers like this. Okay. Now HCF of 3 and 8 is 1. So if the HCF of any numbers is 1, then they are said to be co-prime. So 3 and 8 are co-prime numbers according to the definition. Okay, these are all about the co-prime numbers. Is it clear? Next is composite number. All non-prime numbers are called as a composite numbers. It means the numbers which are not prime are referred as a composite number. Example 4, 6, 8, 9, 10, 12, like this, etc. These are all are not a prime numbers, so they are referred as a composite numbers. Okay, under this you have to remember one point, that is 1 is not a composite number. It means you have to remember that 1 is not a composite number and 1 is also not a prime number. Okay, 1 is not a composite number and 1 is not a prime number. These are all about the composite numbers. Next is perfect number. Perfect number. From this they compulsory ask one question in the CTET examination. Under this topic they did not ask any definition of the perfect number, but they ask like this: identify the perfect number among the following. It means you have to just identify the perfect number. For this we have one trick. You have to follow that. Okay. Firstly consider the given number and it is denoted as n. You have to consider the given number as n. Then find out the factors for the given number. Find out the factors for the given number. We have to find out the factors. Then suppose if I consider the factors of the given number as x, y, z and n. Here why I taken n also one of the factor, because for any number the number itself one of the factor. This I will explain with the help of the example. Suppose if you consider 6. The factors of 6 are 1, 2, 3 and 6. Here 1 also divisible by 6, 2 also divisible by 6, 3 also divisible by 6 and 6 also divisible by 6. So this 1, 2, 3, 6 are the factors of the 6. Here if you observe, the 6 is also one of the factor of 6. Similarly, n, for the given number n is also one of the factor. So I just consider n as the one of the factor of the given number. Okay, such that x plus y plus z equal to n. If any number satisfy this condition, that number we call it as a perfect number. If any number satisfy this condition, x plus y plus z plus so on, which is equal to n, then that number we call it as a perfect number. This, for the better understanding of this, I will just give an examples. Here example is, check 28 is perfect number or not. This is my question, and now we have to find out this 28 is a perfect number or not. For this I just consider this 28 as a n, because it is a given number. So according to the definition I just consider this 28 is equal to n. Now for this 28 I just find out the factors for this 28 according to the definition of the perfect number. I just find out the factors for the 28. The factors of 28 are 1, 2, 4, 7 and 14 and 28. These are all the factors of the 28. After finding the factors, we have one condition, that is x plus y plus z equal to n. This is the condition. According to the definition, this is the condition, x plus y plus z equal to n. Now here n refers to the 28 and this x plus y plus z all are these numbers 1, 2, 4, 7, 14. Now I will just add this all numbers. 1 plus 2 plus 4 plus 7 plus 14, which is equal to 28. Now if I add this all numbers, all the numbers will give the answer as a 28. So 28 equal to 28, which is equal to LHS is equal to RHS. So if LHS is equal to RHS, then the condition is satisfied. So 28 is a perfect number. Next I will give one more example. Check 4 is perfect number or not. For this I just taken 4 is equal to n. N is equal to 4 I just taken. Then I will find out the factors for the 4. 1, 2, 4 is the factors of the 4. Now I will apply the condition, that is x plus y plus so on, which is equal to n. Here n is equal to 4. So x plus y plus so on, which is equal to n. Here x plus y is equal to 1 plus 2. 1 plus 2, which is equal to n. When we had 1 plus 2 is equal to 3, so 3 is not equal to the 4. So 4 is not a perfect number, because here LHS is not equal to the RHS. So 4 is not a perfect number. So these are all about the perfect number, and this video completes the information of the numbers.